My name is Julia Godlewska, and I'm a second-year student of chemistry division at Gdansk University of Technology in Poland. And I have a great pleasure to present you the chemical analysis, which I made with great help, cooperation, and supervision of Professor Piotr Pruściak from Physical Chemistry Department. And I also cooperate with my college of the year, Bartosz Cieśla, who made theoretical calculation, and he's working in inorganic chemistry department. So our object of analysis was K-peptide, which is a small molecule, and it's a part of the hen-egg white lysozyme. And the aim of our study was to investigate K-peptide and dimethyl sulfoxide and 3-methylamine N-oxidase interactions in aqueous solution to get knowledge if K-peptide could form an amyloid structure. As the method we used first at all, ATR FTIR spectroscopy to analyze interactions between solids in their different proportions. The concentration of the MSO or TMAO depends what system we study was kept constant in each solution to diminish the influence of their dissolutions, while the peptide concentration varied. Due to low concentration of the peptide, it was not possible to study directly its vibrational structure. Instead, we focus on the shape and shifts of vibrational bands of the MSO or TMAO in different solutions. We used a variant of the derivative spectra method to isolate and boost spectroscopic signals indicating interactions. Additionally, we used DFT calculations to confirm our spectroscopy results. This method was especially necessary when we study K-peptide and TMAO system. Bartosz used shorter model of peptide, NAGMA, which is similar to K-peptide. He arranged NAGMA with aqua systems so as to optimize and achieve the lowest energy for the system. Moreover, we comparing changes of wave numbers in various structures. It was possible to identify shifts in the spectrums. As results of our study, we obtained the changes visible in spectra were similar to those caused by the hydration of osmolytes. Much fewer water molecules surround the MSO, which results in a lower intensity of the bands for the MSO plus K-peptide system. Moreover, strong absorption band at the about 1062 wave number, which has characteristic form of beta sheets. And this fact confirmed the presence of amyloid structures in the solution. It is visible at lower picture in the three red frames where a black line which demonstrate presence of K-peptide in the solution is beneath red line which shows the MSO. As a result, for K-peptide and TMAO system were obtained, the shift circa 950 wave number towards higher wave numbers for the TMAO in aqueous solution, K-peptide and TMAO system towards to lower wave numbers. Moreover, the bands corresponding to the beta sheet structures, which I told on previous page, shifts towards higher wave number in the presence of the MSO than for the presence of the TMAO, which is present on the second picture. As results of the FT calculations, we confirm the decrease in the intensity of the peaks at about 1000 wave number due to lower amount of water molecules available for the MSO. We identify shifts at about 1250 wave number band as shifts of the twisting band of carbon and carbon and hydrogen band in the metal group of the MSO. The changes in the spectra of TMO are caused by reducing the effective concentration of wave number near the TMO molecules. In summary, in this study, we obtained that K-peptide for amylase structure, dimethyl sulfoxide, does not interact with the peptide in solution, which is in accordance with the osmophobic mechanism of protein stabilization. TMO reacts stronger than the MSO to presence of the K-peptide. We explain changes in the K-peptide and TMO system spectra about 900 wave number. And this study is preliminary study and further investigation are needed to elucidate K-peptide characteristic, role and function. Thank you very much for your attention.